Hi everyone and welcome back to Astronomy 10. Today we're going to go over rings, moons, and Pluto, as well as the debris of our solar system, and go over, look at an overview of our solar system just one last time. Okay, let's look at the moons of our solar system just as a brief overview. So we looked at Earth's moon or our moon in great detail. Um, so we're not going to talk about that one today, but we're going to be talking about some other significant ones or larger ones that are in our solar system. So we have, for Jupiter, we have 4 major moons or larger moons that we'll talk about. Saturn's orbit has Titan, which is a larger moon. Then we have Neptune. We'll talk about Triton, that moon, and we will discuss a little bit about Pluto. Okay, so this depiction shows us the scale of these objects. So for reference, this is Earth, okay, in the lower right-hand corner. And in the upper left-hand corner, we have the Earth's moon. Okay, so you can see the similarities in sizes, or maybe even a little bit kind of the range of sizes that we see in orbit of these planets. Okay, they don't all have to be such a large size compared to its host planet, which for us would be Earth and the moon system. It's actually pretty, I don't want to say similar in size, but they are closer in size than, say, Io and Jupiter. Okay, so it's kind of interesting to look at those differences. So let's look at the few largest moons, and that would be our moon, Kalisto, Ganymede, Europa, Io, and Titan. So these are not in order of largest to smallest, but they do have their diameters here. So Ganymede is our largest with a diameter of 5,270 kilometers. The second largest would be Titan, then Callisto, then Io, the moon, and Europa. Okay, so that is just the diameter. We can also look at the different masses of these moons, and we are comparing them all the time, or not all the time, but we're comparing them in this case to the moon, our moon, Earth's moon. And so if we say that the moon is 1.0, then Ganymede, for example, would be 2 times the Earth's moon mass. Okay, so this is just to kind of give you an idea of what moons we will be looking at, as well as how large they are. So let's first look at Jupiter. So Jupiter has 4 large moons that we'll be talking about, and that is 4 of 79 that are known to us. Okay, 79 known moons. Remember that Jupiter has a faint ring, so just to kind of point that out again. So these 4 moons are Callisto, Ganymede, Europa, and Io, like we see in this image here. Okay, all of these were discovered in 1610 by Galileo, and they are typically called the Galilean moons due to that. Okay, Ganymede and Callisto are about the size of Mercury, so we can compare these two on the right-hand side to the size of Mercury, and Europa and Io are about the size of our moon or Earth's moon. Okay, so we are going to go greater in depth for these moons here. Callisto is our first one. So this is going to be the outermost of the Galilean moons. It's about 2 million kilometers from Jupiter. It orbits Jupiter in 17 days as well as rotates in 17 days. So this is much like the Earth-Moon system. Okay, notice that their orbit and their rotation rates are the same, meaning that they have a synchronous, not they, but Callisto has a synchronous, whoop, rotation, synchronous rotation. Okay, I think I spelled synchronous wrong. So bear with me. Okay, so it's a synchronous rotation that we've got here. It is that if we were on Jupiter, we would always see the same face of that moon. Okay, we're never going to see the backside of Kalisto. Okay, so that's the idea. And you'll see that this is pretty common among these larger moons. So we'll see that in the future here. It has a icy and rocky surface that's covered by craters. You can see that here in this image here. Okay, so you can hopefully see these white, looks like speckles on the surface, and this is actually some icy spires on the surface with dust that's sliding down due to the ice eroding away. So you can see it in this image as well on the right hand side. You can see these, they look like little spikes. I would say they look like little spikes, and as they erode, they're eroding on the opposite side here, and we just get these bright spots on the surface when we zoom out. So that's what we're seeing on in this image here. Okay. Data has been gathered by Galileo's spacecraft that suggests that Callisto may have a subsurface ocean, and in this ocean, life could possibly exist beyond Earth. The interior may have layers of ice mixed with rock and metal, and it has a very thin carbon dioxide exosphere, which is a very thin atmosphere. Okay. Recent research indicates it also has oxygen and hydrogen in its exosphere. All right. So let's move on to Ganymede. So Ganymede is the largest moon in the solar system. So that's one important thing to note. It is, again, tidally locked with Jupiter, aka it has synchronous rotation. Let's try to spell that again. Synchronous. There we go. Rotation. Okay. It has synchronous rotation with Jupiter. It rotates and orbits every 7 days, which is pretty quick. Um, if you compare that to the Earth-Moon system, remember the moon travels around Earth every about 28 days. So we have a smaller planet than Jupiter. You know, Earth is smaller than Jupiter, and this guy, this moon, is traveling, it has to be traveling much faster to go around that larger moon every 7 days. Okay. It has a solid surface made of ice mixed with rock. It has a faint oxygen atmosphere and a subterranean ocean, like we saw in the last one. And in this subterranean ocean, it has more water than all of the water on Earth combined. So if we gathered up all of our water in the oceans, the seas, any kind of waterways, the lakes, rivers, whatever, on Earth, it would still not be anywhere near the same amount as that subterranean ocean. Okay. Um, and due to that, there is definitely a chance that there could be primitive life in that ocean. So when I say primitive life, it could be anything from cells, microbiology type things, maybe little tiny organisms, okay? I'm not talking about there might be, I mean, there could, we don't know yet, but there could be little, I don't know, aliens, I guess you would call them, right? But it's some sort of primitive life, like any sort of organisms or maybe plant life, perhaps, okay? Algae, maybe, I think that would be probably plausible. So, another thing to note about this one is that it has its own magnetosphere, meaning it has a magnetic field around it. So, remember when we talked about Earth, we have a magnetic field that's kind of shielding us from solar activity. Well, Ganymede also has something similar, okay? So a magnetosphere is, I just put the definition here just in case, a region of charged particles that surrounds many planets, but not a lot of moons, okay? So this is pretty rare. Now, in the textbook, we have these two images, and this is the overall image of Ganymede. This one on the right here, though, is pretty interesting because we have this ring here. Hopefully you can see that. And that ring was a crater. Okay, that was a crater, and then we had some sort of tectonic force, and that's what these lines are representing, to pull it apart. Okay, so we have this older impact crater by um, some sort of meteor or meteorite, and it was split apart by tectonic forces. So this must mean there must be some sort of tectonics going on Ganymede or inside of Ganymede to move plates around, okay, much like on Earth. All right, so I'm going to go ahead and pause here, and then we'll continue with the other two um, moons for Jupiter.